Hi, everyone. My name is Shomo, and I want to take a few minutes to run through some basic concepts in machine learning and artificial intelligence. In particular, I promise that at the end of this short video, you will understand how machine learning models are trained and how one can use these machine learning models to generalize beyond data that it has seen before. Stated in these terms, it's a very broad and ambitious goal, but machine learning is a very practical and empirical science, and machine learning scientists have come up with beautiful empirical ways and practical ways of training diverse models and making sure that they can generalize to unseen data. And what I'm about to tell you is true for all kinds of machine learning models, ranging from support vector machines, deep neural networks, logistic regression, what have you. I will leave some more resources in the video below. Many of the resources that I'm teaching from are from an excellent Coursera course by Professor Andrew Ang, and a book called The Introduction to Statistical Learning in R by Tip Shirani et al. I will leave the links to all these resources and a GitHub repository in the video below. But in the meantime, I just want to step you through a basic problem that many machine learning models can face. Say that you have data in these blue points right here, and you're trying to fit a model, in this case, a polynomial of some degree, to this data. One way to do this is that you just fit your model to whatever data you have. And in this case, you feel like your model is doing a really, really good job. However, there's actually there's bad news because you are actually overfitting. What this means is that you are essentially giving it all the data that you have, and your model naturally trained on it, does a really good job, but actually cannot generalize beyond the data that it's seen before, that it has seen already. This is really bad because today you have this data, tomorrow you might collect additional data, and other people surely are going to say do more experiments or do some other simulations. They're going to generate even more data. So if your model is really laser focused on that particular data that it has seen, it really cannot generalize to other data sets that it has seen before. On the other hand, your model could do a really bad job. It's called underfitting on whatever data you have given it. That also is bad because now it's really not doing well on what data you have given it. What you want to do is you want to be hit the sweet spot, strike a good balance between neither overfitting nor underfitting. Doing well on whatever data you have given it, but also having some leeway, some wiggle room available so that it does very good also on unseen data. And how do you do that? Well, again, stated very broadly in those terms, that is a very, very ambitious goal. It's essentially how, higher organisms learn in a way that it has seen some data, but it really does well, can also do well on unseen data. There's a really, really hard problem. But as I mentioned, machine learning scientists, being empirical, have come up with an extremely empirical and practical way of doing this. And one practical way of doing this is to say, well, say you have n data points here, 1, 2, 3, up to n. It's really a bad idea to give all this data again to your machine learning model, because then, of course, it's going to fit your data really well, but won't be able to generalize. But what is in turn, it's done, and this is the solution to the problem that I said, is that you give little bits of data to your machine learning model, pretend that it hasn't seen this other bit of data. So you train your machine learning model on this bit here, but just don't tell it about this other bit that you have just held out. Now you train your machine learning model on this blue data right here. It's called the training set. And then you test how well it does on this unseen data. because you have held out and the machine learning model doesn't know that you have this additional data. And you do that repeatedly, any machine learning model will have some knob, some tuning parameter. Maybe if it's a deep neural network, it's the number of hidden nodes. If it's a decision tree, it's the depth of the tree. If it's logistic regression, it's the number of variables that go into it. Any any model will have some knob. And what you essentially do is you train your model on this blue bit here, and you tune your knob on this bit, on this validation set here. In effect, that is what allows you to achieve that sweet spot, that just the right balance between doing well on the training data, that's the data that it has seen, but keeping some wiggle room for unseen data that it hasn't seen before. This is a very, very key concept in machine learning. That is, you sort of train models that can generalize beyond data that it has seen. And this concept, this very critical concept, is true again whether you are doing deep neural networks or you're doing support vector machines or any other model. Uh, all the nitty-gritties and the nuts and bolts of these models are really, really important, but everything will fall into place if you really understand this critical concept here thoroughly. And this is one of the basic fundamental tenets of uh, machine learning and indeed statistical learning. This is true in statistics or machine learning or any kind of mathematical model building that you are doing in the sciences. This is this key tenet allows you to generalize beyond sort of data that you have seen before. I hope this video sort of clarifies some of these concepts. I have left some links to resources in the video below. If you scroll through the page, you'll be able to see those links. I've also compiled some of these into a GitHub repository that you can go through. My intention with these videos is to completely demystify artificial intelligence and machine learning and make it as accessible as possible to general audiences so that one can cut through all the hype that is out there. Hopefully that will allow a more rational dialogue with AI and the great role that it can play in human society. I hope that this video was helpful. If you have any comments or feedback, please leave it in the comment section below. And please take some time to go through the resources and the links below. I wish you all the best in your endeavors. Thank you so much.